of the tangent of the inverse sine of root 3 over 2. So this is a composition of functions. So when we have the tangent of the inverse sine of root 3 over 2, and what I'm writing on Microsoft Paint could be a model of what you are writing on your solution paper, is we first need to find the inverse sine of root 3 over 2, and we find out whatever the heck that is, and then from there we determine what the tangent of the value is. So first let's think about the inverse sine of root 3 over 2. In order to solve this, we either use our calculator or our unit circle. I'm going to solve this using my knowledge of the unit circle. So we know that the inverse sine of root 3 over 2 is asking ourselves the sine of what angle produces the value of root 3 over 2. And if we remember our unit circle values, when theta is 60 degrees, the sine of theta is root 3 over 2. That's one value. But we also know that there's a second trig value where the sine of theta is root 3 over 2, and that is at 120 degrees. That will also produce a sine value of root 3 over 2. So this is a visualization on the unit circle. 20 degrees. The sine value would be root 3 over 2. So that's kind of the intuitive logic. So anyways, if the sine of 60 is root 3 over 2, the inverse sine of root 3 over 2 could be either 60 degrees or 120 degrees. So we can say that the inverse sine of root 3 over 2 is 60 degrees or 120 degrees. And now that we know the inverse sine of root 3 over 2 could be 60 degrees or 120 degrees, what we can evaluate is that we can either evaluate the tangent of 60 degrees or the tangent of 120 degrees. And here, the tangent of 60 degrees, once again, I just know this from my unit circle. That's going to be the square root of 3. And the tangent of 120 degrees is going to be equal to the negative square root of 3, because these are both reference angles. So the answer choices here for what is the value of the tangent of the inverse sine of root 3 over 2, that would be equal to the square root of 3 or the negative square root of 3. So that's problem 1. Any questions about the process of problem 1, or a question about how you would do it on a calculator, or any of that? Okay, yes, Fergus.
So would there be a difference if sine wasn't there to the power of -1?
Well, so that's not sine raised to the power of -1. That's inverse sine. So normally you have your angle input and your trig value output. Your angle input is 60 degrees. Your trig value output is the sine of 60 degrees is root 3 over 2. But when you have that -1 there, that's not saying sine raised to the -1. That's saying inverse sine. And the inverse function switches inputs and outputs. So now the input becomes root 3 over 2, and the output becomes 60 or 120. So when you see inverse sine of a value, you're saying what trig value when the angle is inputted into the trig value, produces the value shown. So when you see the inverse sine of root 3 over 2, it's asking the question, what angle can I input into the sine function and get a value of root 3 over 2? So you can say that the sine of 60 is root 3 over 2, or the sine of 120 is root 3 over 2. And you can verify that with your calculator. You can verify that with your unit circle. All right. So I'm going to erase this unless we have any more questions. All right, I'm going to hit the delete button, and we're going to keep on going. Find the asymptote of the logistic function, 30 over 4 plus 3e to the negative 3x. And so this is definitely a question where it's going to make sense to use Desmos or a graphing calculator. I'm going to use Desmos here. So the equation here is y is equal to 30 over 4 plus 3e to the negative 3x, okay? And we see it's called a logistic function. It looks like a logistic function. The horizontal asymptotes are a consistent y value that the function approaches as x approaches positive and negative infinity. So this value right here, we are approaching from the left and right. Watch my cursor. That's a horizontal asymptote we're approaching. As x approaches infinity, that y value is approaching a value. And as x is approaching negative infinity, the y value is approaching a value. Hopefully we can see that as x approaches infinity, y is approaching 7.5. And as x is approaching negative infinity, y is approaching 0. So our two horizontal asymptotes, hopefully you can see it, is y equals 7.5 and y equals 0. So as far as showing our work, we can just say we graphed the function. The function will look like this. We have a horizontal asymptote and then a logistic function, and our two horizontal asymptotes were at y equals 0 and y equals 7.5. That's one horizontal asymptote. This is another horizontal asymptote. So our two asymptotes are going to be horizontal asymptotes will be y equals 0 and y equals 7.5. Alright, moving on to the next problem. I'm going to find the domain algebraically and with my graphing calculator for this one. Find the domain of the square root of x minus 3 over x plus 2 times x minus 6. Now, I just need to find my domain restrictions. My domain restrictions are my denominator values can't equal 0 because I can't divide by 0. And my term under the square root can't be a negative number because you can't take the square root of a negative number. Then you find the values of x that satisfy this. So I look at my restrictions. If x plus 2 cannot equal 0, x cannot equal negative 2. If x minus 6 cannot equal 0, x cannot equal positive 6. If for the square root value, x minus 3 that's the value that has to be greater than or equal to 0. Because if x minus 3 is less than 0, it's negative, and you can't take the square root of a negative number. So I need to say x minus 3 must be greater than or equal to 0. Add 3 to each side. X must be greater than or equal to positive 3. And now I look at these domain restrictions, and I have to choose the most restrictive domain restriction. So for example, if x must be greater than or equal to 3, then any value below 3 is completely out of the question. So all values 3 or higher, so that automatically excludes, anything around negative 2. So that means any value greater than 3 is going to be in the domain, except for, we have this restriction right here, x cannot equal 6. So we also have to exclude x is equal to 6. So how this would look like in interval notation, this would look like we go from 3 inclusive all the way up to 6, but we cannot include 6. Then we have a union, and we go from 6 to infinity, and this defines the domain of this function. So that's kind of how you would show your work. And the domain in interval notation is from 3 bracket to 6 parentheses union, and we go from 6 bracket to infinity parentheses. All right. While I'm showing this graph on Desmos, if anyone has any questions at all about this type of problem, I'm going to. So you can look at the scratch work here. What does anybody have? So seriously, if there are any questions at all, let me know. And I'm showing you that you can find a domain on Desmos. We just have to be a little bit careful and be able to recognize key values. All right. So here, if you graph the function on Desmos, you can also, if you know what you're to look for, you can find the domain. We can see that all the x values start at 3. There's no x values to the left of 3, 0. So our x values start at 3, and then we approach 6, but we never touch it. We have a vertical asymptote there. So this is what the function looks like. X has to be greater than 3, but it can't equal 6. But once again, you have to really bring your cursor, move your cursor along, especially if there's a potential hole in the function, to find out what your excluded values are. Okay, so that's problem 3. Once again, any questions at all? Okay. All right, let's move on to problem 4. Find the magnitude and the direction of the vector -5, 8. And what this vector -5, 8 is indicating is that -5 is the horizontal component and 8 is the vertical component. So if you're starting at the origin, when we look at that vector of -5, I see a horizontal component moving left 5. So we go left 5. And then we move up 8. And this is approximation. And the actual vector, which I'm going to show in red, or I'll do blue, is going to be from my beginning point to my end point, and that is the vector. Now, to find the magnitude, all I have to do is use the Pythagorean theorem. 5, because this creates a right triangle. So I can find 5 squared plus 8 squared is equal to my magnitude squared. That's just using the Pythagorean theorem, which means 25 plus 64 is equal to my magnitude squared. 64 plus 20 is 84. 84 plus 5 is 89. So if 89 is equal to my magnitude squared, my magnitude is equal to the square root of 89. So you could leave it like that, or you could evaluate in your calculator if your multiple choice answer is looking for something in decimal form. But our magnitude is the square root of 89. Now here's a question of direction. We can use right triangle trigonometry to find our direction. But I want you to take note that this is a quadrant 2 angle. Because if we're actually looking at the quadrants of this angle, I move down, I'm just drawing the quadrants. The actual angle is going to be starting at the initial position and then rotating up to the vector right there. So that's going to be our actual angle. So in quadrant 2, I will need to find my reference angle of the right triangle and subtract that from 180. Because this is starting from right here, that's 180 degrees. We subtract my reference angle by 180 to get my actual angle. So let's find the reference angle first. To find this reference angle, I need to find the inverse tangent of 8 over 5, because SOHCAHTOA, the tangent is the opposite over the adjacent, so the tangent of theta is 8 over 5, the opposite over adjacent. And to find the angle, I find the reference angle, I find the inverse tangent of 8/5. Here, I go to mode, degree mode. So I switch from radian mode to degree mode in my TI calculator. I hit enter. And I find the inverse tangent of 8/5. So I'm in degree mode. So that's a very small number. But I can just subtract this value from 180. Oh, and sorry, I didn't hit the second button. So I find the inverse tangent of 8/5. So sorry, make sure you hit second, and that's 57.999 degrees. And then I do 180 minus this value to find my actual angle. And my answer is 120.005 degrees. So I find my inverse tangent, that's approximately 57.99, but my actual direction is equal to 180 minus 57.99, which is equal to 122.01 approximately. So that's all the work for problem 4. And so the magnitude is equal to the square root of 89, and the direction is equal to 122.01 degrees. And now obviously I've been taking my time to explain things, but really if you know what you're doing and you're quickly punching this in your calculator, you can solve this problem in less than a minute. Okay, yes? What was that? So the video? I'm making it right now. So what was that? Mm-hmm. And so you'll have access to it to study for it tonight. In triangle ABC, side A, so this is side A, is 10 meters long. Side B is 20 meters long. All right, this is side C. Side C is not specified. And angle C is 40 degrees. What is the length of side C? We have a side, an angle in between. So we have two sides and the angle in between them. And we need to find the side opposite the angle. This is a classic law of cosines problem. And so I'm just going to, this is law of cosines. Here's how you set it up. Law of cosines. Side C is equal to the square root of a squared, 10 squared, plus b squared, 20 squared, minus 2ab, minus 2 times 10 times 20, times the cosine of my angle, which is 40, times the cosine of 40. All right. So I can find the square root of 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 40 degrees, and that's equal to 13.91, and so that's the length of angle C. Or that's the length of side C. So C is equal to 13.91 meters. And so in your answer choice, we can say 13.91 meters is our solution. Now, once again, to me, this is either like you know the law of cosines, you know how to apply it, or you don't. But that being said, any questions on just in general applying the law of cosines? A lot of times, what trips people up is being able to draw the triangle and knowing that they have to use the law of cosines. So if there's any questions on that ground, let me know. Okay. Anything? All right. Okay. What values of x, where x is an angle in radians, that make the following equation true? And then the equation is the cosine of 2x is equal to the sine of x. Now here's the deal. This is a trick that you got to just recognize for any type of equation. Anytime you can have two equations that you can graph, and they're equal to each other, and you're solving for x, if you can graph both equations, find the x values of the point where they intersect, that will be the values. So if you can have one equation be the cosine of 2x, the other value will be the sine of 2x, and I am going to make sure that I am in radians. If I can find the intersection, and find the intersection between 0 and 2 pi, remember If pi is 3.14, 2 pi is 6.28, because 2 pi is a full rotation around the unit circle. That one intersection is pi over 8. Another intersection is 5 pi over 8. A third intersection is not, and actually, those aren't intersections because the problem said the cosine of 2x and the sine of x, so make sure you type in your problem correctly. One solution is pi over 6. Another solution is 5 pi over 6. Another solution is 3 pi over 2. And if you notice, after 6.28, the solution just becomes 13 pi over 6. But really, periodically, these are the solutions, and you can just add or subtract 2 pi to them in order to get a proper solution. So that's pi over 6, 5 pi over 6, 3 pi over 2. Pi over 6, 5 pi over 6, 3 pi over 2. So as far as what showing your work would look like, you could say that you graphed the function, right? So you can say you graphed the function, then you can draw an approximation of the graph. You have one function modulate faster than the other. Then you have one function modulate slower than the other. And you can say that their intersection, the points of intersection, would be when x equals pi over 6, when x equals 5 pi over 6, and when x equals 3 pi over 2. So it obviously does not have to be pretty, but if you can just kind of in general draw a sine graph and draw the points and then point out where your points of intersection are, that really just demonstrates you graphed it in your calculator and you knew what to do. So once again, as you would actually write this, you would write this as x is equal to pi over 6 radians, and then you could write plus 2 pi n, that indicates all angles coterminal, 5 pi over 6 plus 2 pi n, and what that plus 2 pi n means, you can always add or subtract 2 pi and you would get a coterminal angle, because though, as you can see on the graph, the pattern of the sine waves and the cosine waves go on infinitely. And then 3 pi over 2 plus 2 pi n. Any question or point of confusion about any step I did for this problem, please don't be shy to raise your hand and let me know, because I'd be happy to address it or explain it further or clear up any misconception. But feel free, but you gotta let me know if you have those. Okay. Now we have f of x is equal to 2x squared minus 5x plus 2 over 2x squared minus x minus 6. We're supposed to find x-intercepts, y-intercepts, holes, and vertical asymptotes. Oh, that changes everything. Okay. Alright, in that case, we can factor this out. So this would be x minus 2, 2x minus 1. 2x times x is 2x squared. Negative 2 times 2x is negative 4x. Negative 1 times x is negative x. Negative 4x plus negative x is negative 5x. Negative 1 times negative 2 is positive 2. 2x squared minus x minus 6. This could factor, once again, this becomes 2x and x. This will factor into, multiplies to negative 6, adds to negative 1. We could have x minus 2 and 2x plus 3. 2x times x is 2x squared. 2x times negative 2 is negative 4x. 3 times x is negative 3x. Negative 4x plus 3x is negative x. 3 times negative 2 is negative 6. So this, now that this is the case, I can look at where my horizontal asymptotes, my vertical asymptotes, my holes, and my x and y intercepts are. Okay, so one is the x minus 2, I see that this cancels out. Because the x minus 2 cancels out, I know it's a hole. So if x minus 2 is a factor creating a hole, that means x minus 2 cannot equal 0. X cannot equal 2, which means I have a hole at x equals 2. Two x plus 3 cannot equal 0. This does not cancel out, so it's a vertical asymptote. 2x cannot equal negative 3. X cannot equal negative 3 halves. So that's a vertical asymptote. To find, so once again, those are my hole, that's a hole, that's my vertical asymptotes. To find the x and the y intercepts, I just need to find the y-intercept. I need to set x equal to 0. To find the x-intercept, I need to find the y value equal to 0. So to find the y-intercept, I set an x value equal to 0. So that's going to be equal to 2 times 0 minus 1. So my y-intercept, my x value is equal to 0. And my x terms canceled out here. So I can just do 2 times 0 minus 1 over 2 times 0 plus 3. 2 times 0 is 0. 0 minus 1 is negative 1. And 0 plus 3 says it becomes negative 1/3. So my y-intercept is 0, negative 1/3. My x-intercept is that I have, the x-intercept is when y is equal to 0. So I have 0 is equal to 2x minus 1 over 2x plus 3. Multiply each side by 2x plus 3. Multiply the left side by 2x plus 3. 0 times 2x plus 3 is still 0. 2x plus 3 and 2x plus 3 cancels out. So I still have 0 equals 2x minus 1. Add 1 to each side. 1 is equal to 2x. Divide each side by 2. X is equal to 1/2. And my x-intercept is 1/2, 0. So, as far as my x-intercepts are, my x-intercept is 1/2, 0. My y-intercept is 0, negative 1/3. I have a hole at x equals 2, and the vertical asymptote at x equals negative 3 halves. So those are just writing down my solutions and we have the function in Desmos. If you know what you're looking for, you can easily find these values and more in Desmos. We clearly see we are approaching -2 for our vertical asymptote. Or sorry, -3/2. So x equals -3/2, but you have to know what you're looking for, okay? So you start zooming in here. You'll see that -3/2 is the value that you're approaching, and you can do this by scrolling down or just and looking what your x input is approaching. So -1.3. You can if you can visualize it, that will be your vertical asymptote. Secondary thing is your x and y intercept. We have an x-intercept at 0, -1/3. That matches up. We have a y-intercept. So that's a y-intercept at 0, -1/3. We have a y-intercept at 1/2, 0. So that is the case. And then even if you were asked to find horizontal asymptotes, find out what you're approaching here. We have horizontal asymptotes approaching y equals 1. And that's because the ratio of our leading coefficients are 2/2, which is 1. So this is even easier if you have a multiple choice problem. And that's because all you have to do is you can, if you're confused about what the vertical asymptote is, type your vertical asymptote into Desmos after you graph the function, and if it doesn't match, it doesn't match. Alright. So sorry, took longer. Make sure that you copy down the problem correctly, because if you don't, you'll look foolish, like I did, but that's okay. Any questions on 7? Okay. Problem 8. 2 sine squared of x plus 3 sine of x plus 1 is equal to 0. Alright. This is very much a Desmos problem. Or sorry, a graphing calculator problem. I have shown a way to solve this without it, but in the interest of time, I'm just going to show you an efficient way to go about it. 2 sine squared of x plus 3 sine of x plus 1 is equal to 0, which means we are looking for the value in which this intercepts the y-axis. So this would be equal to 0 at 7 pi over 6, 0, 3 pi over 2, 0, and 11 pi over 6, 0. So how we would show our work for this, we would sorry about that. 7 pi over 6, 3 pi over 2, 11 pi over 6. We would graph the function. We would draw the x-axis, and we would have those x-intercepts when is equal to 0. That would be 7 pi over 6, 0, 3 pi over 2, 0, and 11 pi over 6, 0. And that's just a quick way you could solve that problem. So here, this would be x is equal, and once again, these values, all coterminal values included here. So what do we actually write for my answer? That would be 7 pi over 6 plus 2 pi n plus, and then x is equal to 3 pi over 2 plus 2 pi n, and then x is equal to 11 pi over 6 plus 2 pi n. All right. If the cosine of A, also, questions on this problem? Sorry about that. So this is, any questions about how you would input that into the calculator, find the x-intercept, click on it? Okay. The cosine of A is 12 over 13, and A is in between 270 and 360, which means that our angle is in quadrant 4. So the cosine of A is 12 over 13. What is the value of the cosine of 2A? So let's think about this. Let's just draw our reference triangle. We have a nice reference triangle with our angle. If the cosine of our angle A is 12 over 13, from SOHCAHTOA, 12 is the adjacent side and 13 is the hypotenuse. So we have an adjacent side in 12, a hypotenuse in 13, and we have 12 squared, and what we need to do is find the value of our angle, okay? And so if the cosine of A is 12 over 13, and we're trying to find what our angle is, we can just use inverse cosine. The inverse cosine of a reference angle is the inverse cosine. You can take the inverse cosine of both sides. So you're going to take the inverse cosine of the right side and the left side. So that means the inverse cosine of 12 over 13 is equal to A. Here's what happened. I just took the inverse cosine of the left side and the inverse cosine of the right side. What happened is inverse cosine cancels out cosine, giving me angle A. But then I had to take the inverse cosine of 12 over 13 as well. So let's find what the reference angle A is. So now in degree mode, I find the inverse cosine of 12 over 13. That's 22.61. So my reference angle is 22.61. So my reference angle is going to be equal to 22.61, but we have indicated we are in between 270 and 360. So this reference angle in quadrant 4, as has been indicated to us, means we have to subtract our reference angle from 360. So to find our actual angle A is equal to 360 minus 22.61. 360 minus 22.61. So I do 360 minus this value, meaning our quadrant 4 angle is 337.38 degrees. 337.38. So that's equal to angle A. A is equal to 337.38. Multiply this by 2 in my calculator as well. 2A is equal to 674.76. And then my last thing is the problem is asking for the cosine of 2A. So I find the cosine of 2a is 674.76, so just find the cosine of that. And the answer is 0.704. If your multiple choice is in radicalized form, just convert all your multiple choice answers, and whichever one would be equivalent to 0.704 would be the correct answer. So the cosine of 2a is equal to the cosine of 674.76 degrees, and that's equal to 0.704. Okay? So approximately. So the cosine of 2a is approximately equal to 0.704. Okay. So this is kind of a process of using inverse cosine to find the reference angle. Use your reference angle to find your actual angle. Multiply your actual angle by 2, and then find the cosine of that value. All right. Any questions about the process used in this problem? Once again, if you do have questions, don't be, feel free to speak up if you do. Otherwise, moving on to problem 10. All right, simplify cosecant over cotangent of theta in terms of sine and cosine. So we have the cosecant of theta and the cotangent of theta. Cosecant of theta can be rewritten as 1 over the sine of theta. That's just part of its reciprocal identity. And cotangent of theta can be rewritten as the cosine of theta over the sine of theta, because it's the reciprocal of tangent. So if tangent is sine of theta over cosine of theta, cotangent, you can just flip the numerator and denominator. So this becomes 1 over the sine of theta divided by the cosine of theta over the sine of theta. So let's look at how we divide fractions. If we have 1 over the sine of theta divided by the cosine of theta over the sine of theta, that's equivalent to, look at how we divide fractions, 1 over the sine of theta times the sine of theta over the cosine of theta. Now, I can see that the sine of theta cancels out. So now I just have, in terms of sine of theta and cosine of theta, I have 1 over the cosine of theta, but that's also equal to the reciprocal function secant of theta. So as far as an answer here, the answer here would just be 1 over the cosine of theta or the secant of theta. Now, I think this is a very important skill for you to be able to break this down. Worst case scenario, you pick some value for theta, 30 degrees, 40 degrees, doesn't matter. You plug in the cosecant of theta over the cotangent of theta into your calculator. You plug in whatever your answer choice is in. If your answer choice is 1 over the cosine of theta, you plug in that as well. Whatever spits out the same answer choice, that's going to be your solution. And remember, your calculator can't use cosecant, secant, or cotangent. So if you wanted to do the cosecant of theta over the cotangent of theta, you would have to do, for cosecant, you have to do alpha y 1 over the, let's say you want to do 1 over the sine of, let's say you want your theta value just be 30, over, and then cotangent of theta is the cosine over sine. So then you can plug this in. Cotangent is cosine over sine, so you do the cosine of 30 over the sine of 30. You could also do 1 over the tangent of 30. That would also, cotangent is cosine over sine, or 1 over tangent. And then that would get you a value of 1.154, and you find 1 over the cosine of 30, and that would also be 1.154. And so you see that your values would be the same, and so that's how you evaluate this in the calculator. But this way is the kosher way, as they would say. All right. Any questions at all on number 10? Okay. Well, there. Okay. Problem 11. Solve for x in terms of b. 16 to the 3x minus 3b is equal to 1 over 32 over x plus b. And here is where we really want to understand how what a common exponent could be. So 16, I can rewrite that. I need to find a common exponential function with a common base. So when I think about 16, I think about 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's going to be 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and 2 to the fourth power is 16. So 16 is 2 to the fourth power. And that's obviously raised to the 3x minus 3b. 1 over 32, remember that could be written as 2 to the fourth power is 16, 2 to the fifth power is 32, 2 to the negative fifth power is 1 over 2 to the fifth power. So this is equal to 2 to the negative fifth power times x plus b. So now that I have x in terms of b, now that I have rewritten with a common base, I need to understand my law of exponents that I can, if one exponent raised to another exponent, I multiply them. So this is equal to 2 to 4 times 3x is 12x. And 4 times negative 3b, and sorry, that's a b, not a 6, is going to be negative 12b. 12x minus 12b is equal to negative 5 times x is negative 5x. So that's equal to 2. Negative 5 times x is minus 5x. And the negative 5 times b is minus 5b. And once I have a common base, that the reason why I was looking for a common base, so once I have a common base, I can cancel out the bases and just set the exponents equal to each other. So now I can do the problem 12x minus 12b equals negative 5x minus 5b. So if I want to solve for x in terms of b, I'm going to add 5x to each side, add 12b to each side. 5x's cancel out. 12 plus 5 is 17, so I have 17x on the left-hand side. The 12b's cancel out. Negative 5b plus 12b is going to be negative 5 plus 7. So 12, this is going to be 7. So negative 5 plus 12 is equal to positive 7. This is 17x is equal to 7b. I divide each side by 17. And then the 17s cancel out. And x is equal to 7b over 17. And because I'm solving for x in terms of b and I've isolated x, that would be sufficient. Now, if I wanted to solve this with a calculator, I need to just find a placeholder value for b and understand that ratio, and then plug that into my answer choices. So if I was wanting to solve this very quickly using Desmos, I would have pick a value for b. An easy value for b would be 1. I would, if I wanted to solve this in the calculator, 16 to the 3x minus 3, assuming b is equal to 1. And then I have 1 over 32 to the x plus, if I wanted to, put that in parentheses, to the x plus b is 1, and then finding the intersection. And sorry, that's 3x minus 3b. So let me put that in parentheses. 3x minus 3. So now I'm looking for the intersection. And where do they intersect? But at 0.4118. And looking at so that intersects at 0.4118, and if I can do 7 over 17, that's 0.4118 approximately. So I could test. So if I can plug in B1 for B, and then test my answer choices, I'll be able to find my solution. So there's a bunch of different creative ways you can solve this problem. Any questions about any of the ways you could use to solve this problem? What way do you guys think you would use? Do you think you would plug in a simple value for B and find the intersection in your calculator, or find the common base and use the law of exponents? Common base, okay. Cool. I think I like the common base method better, but I wanted to show you that this way was possible. All right. Okay. Sorry, that was, I forgot to write down the answer. That was what, x is equal to 7b over 17, right? All right. 7b over 17. Okay. Solve for x times the log, and just a heads up, if you write log without indicating a base, and it's log and not ln, that's called the common logarithm. That means log base 10. Log of 9, and so we solve for x, and so sorry, I've actually confused myself because I didn't write the problem. I should have written solve for x, comma, the log of 9 minus x equals 7 plus the log of 5x plus 3. So I have the log of 9 minus x is equal to 7 plus the log of 5x plus 3. My first step is to get all my logs on the same side. So subtract each side by the log of 5x plus 3. And now I have the log of 9 minus x minus the log of 5x plus 3. That's equal to 7. And I have to use my rules to condense the logarithm. And when I condense the logarithm, I have to have my first term, and I condense, I see I'm subtracting, so that I want to subtract, that's going to be the quotient rule. The first term is the numerator, the second term is the denominator, so now I have the log of 9 minus x over 5x plus 3 is equal to 7. I have to know that a common logarithm is log base 10. And in order to get my x terms out of the parentheses, out of the input term for the logarithm, I'm going to have to swoosh that logarithm. So the base of the logarithm is 10. The base of my converted exponential function is 10. Raised to the 7th power is equal to 9 minus x over 5x plus 3. And so now I need to solve for x. I'll have 10 to the 7th, by the way, is 10 million. I'll have 5x times 10 million. That's 50 million x. And then plus 3, 10 million plus 3, that's going to be plus 30 million, is equal to 9 minus x. So what I'm going to do is I'm going to add x on the left-hand side, on both sides, and then subtract 30 million on both sides. So 50 million x plus 1x is going to be 50 million and 1x. And then 9 minus 30 million, that will be equal to 29,999,000. And sorry, that's if I'm subtracting, that will be negative 29,999,991. Because that's positive 9 minus 30 million. And then the last step is I just divide each side by 50 million and 1 to get x. So to get my x value, I pull up my calculator and I input negative 29,999,991 divided by 50 million and 1x. Yes, Michael. Yes, you may. So that's negative 0.599999. So that's negative 0.6. So negative 0.59999999. You can approximate that as negative 0.6. So this is approximately equal to negative 0.6. Now I also wanted to show you how you do this in the using a graphing calculator. So here, what we would do is we have one equation is the log of 9 minus x. The other equation is the log of 5x plus 3. So you can put one equation in row 1, one equation row 2. You look for their intersection, and you see that the intercept, it's log of 9 minus x, and the other equation is 7 plus the log of 5x plus 3. And I see the x value of that intersection is negative 0.6. And because I've calculated that intersection, what that means is that's the x value where that's the correct solution. So I really think it shows good thinking to show your work and use your log rules to solve this problem. That being said, I really like the efficiency of solving the problem this way. So having access to a calculator can be a blessing, especially I remember the days when I did not have access to a calculator taking this course, and it can make some problems a lot easier. Okay. So indicate the transformations of y is equal to, and the parent function is just x cubed, negative 4x minus 16, all in the quantity of that, cubed minus 1. And these are the type of problems where I actually think you confuse yourself by having access to Desmos. It's easier just to factor things out and indicate the transformations. So y is equal to negative, but now we have to factor out the coefficient for the x. We always do this. Every time you always factor out the coefficient of x. So if I factor out a 4, I'm going to have x minus 4 cubed minus 1. And now I indicate my transformations. This negative sign, that's an x-axis reflection. X-axis reflection. So is there a vertical reflection across the x-axis? Yes, there is. All right. There is no coefficient outside of the function. If there was a coefficient outside the function right here, there would be a vertical dilation, a vertical stretch or compression, but there isn't. So there is no vertical stretch or compression. Now I see this 4. There's no negative sign in front of the 4, so I know there is no horizontal reflection across the y-axis. So there is no horizontal reflection. Now I look at this 4. This does mean that there is a horizontal dilation. In fact, there's a horizontal shrink. So this is a x-axis reflection. This is a horizontal shrink. And horizontal, you do the opposite of what you think. So instead of being by 4, it's by 1/4. So our horizontal dilation is by 1/4. All right. And now that we've factored out that 4, x minus 4, switch the sign. That's a shift to right 4. So our horizontal shift is right 4. All right, and last is my vertical shift. That minus 1, it's outside the function, so it does exactly what I think it does. That moves us down 1. So our vertical shift is down 1. Okay. So that's 13. It's tough If you don't know what the steps to do, it's not tough if you know to factor and what to identify. Okay. So that's 13. Any questions before I move to 14? Yes, Toby. Yes. All right. Drawing our triangle, okay? The distance across the river is side length AB. So if we have a river, the distance across the river is side length AB. So this is A, this is point B. Distance BC, so this is a triangle. BC is 700 meters. Angle B is 110 degrees. Angle C is 15 degrees. Determine the distance across the river. So here's what we're going to have to do. We need to know that the sum of the angles in the triangle add up to 180. And so that 180 minus 15 is 165. And 165 minus 110 becomes 65 minus 10, which is 55 degrees, meaning angle A is 55 degrees. So that's 55 degrees right there. It's a little bit hard to see, but that's 55. And now that we have, if we're trying to find side length AB, which by the way is called side C, we can use the law of sines because we have an angle, the side that's paired with it, then the second angle, and then the side that's paired with it. That's what we need to find. So we can say side length C over the sine of C. So once again, this is law of sines. C over the sine of C is equal to 700 is equal to side length A. 50 is equal to side length A over the sine of A. This is using the law of sines. So that means C over the sine of C, which is 15, is equal to A, 700, over the sine of A, which is 55. So it's the sine of 55. So multiply each side by the sine of 15. C is equal to the sine of 15 degrees times 700 over the sine of 55. All right. So then you take the sine of 15 degrees, all right, times 700, and then you divide that by the sine of 55. That's going to be equal to 221.171, and that is the distance across the river. Okay, so that's 14. Any questions on 14 before we do 15? Okay. Let's do 15 then. So, how far is the sun from the center of this new planet's orbit? This is just it's going to require us to draw an ellipse to understand. we have the center of the ellipse, and the sun is at a focus. So it could be any of the foci, but I'm going to choose one. So this is the center, this is the sun. Okay, right there, that's the sun. All right. We need to find the distance between the sun and the center, and we are given we're given the equation of the ellipse. What we need to realize is that the distance that this distance right here is A, and the distance from the sun to the center is C. Okay? So actually, what we need to find is just C. If we can find C, we can find the value of this orbit. So A is going to be the square root of 950,050 squared. B is going to be the square root of 920,000 squared. And we need to find C. So here's the deal. You have the sun at the focus, you have the center. If you can find the focal length, that is the distance from the sun to the center, and that's what the question is asking for. So we use the Pythagorean relation for an ellipse. A squared plus B, A squared minus B squared equals C squared. So A squared minus B squared equals C squared. 900 and so here I'll write out the calculator function before I put it in. So that means that C is equal to the square root of A squared minus B squared. So C is equal to the square root of A squared, which is 950,050 squared minus 920,000 squared. So this is equal to C, A squared minus B squared. And so that's going to be 237,054. So C is equal to 237,054 kilometers from the center of the orbit. Okay, so the rest I'm going to post the recordings for the entire thing, so you can check your answers for all of them, and so you can, those will be up by the end of third block. And go. All right, so we are doing problem number 16, and we need to find the foci of the hyperbola negative x squared plus 4x plus 4y minus 16y minus 16 equals 0. So oh, right, that's 17. So we're doing 16. Okay, getting it together in 3, 2, 1. All right, come on. Let's look at the expectations for direct instruction. Okay. Seriously, let's look at those expectations. Our hyperbola is x squared minus y squared minus 4x plus 4y minus 9 equals 0. My first step in rewriting this hyperbola is to group the x squared and the x terms, the y squared and the y terms, and get the constant on the other side of the equal sign. So I'm going to have x squared minus 4x. I'm going to leave space for a complete the square term, minus
y squared minus 6, y squared plus 4y is equal, I'm going to set the equal to positive 9. Alright? So that's going to be equal to 9. Alright, so what we do is we got to complete the square. We use negative 4, divided by 2, and that's equal to negative 2. Then we take our negative 2, we square it, and that's equal to 4. So we add 4 to each side. Now for the y term, I group my y terms in parentheses. Alright, and I take my 4, I divide it by 2, that's equal to 2, alright, and then I square it, and that's equal to 4, and I add 4 to each side. Now if I...
Can you slow down for a second?
Yes. Now, one thing to consider is that if I'm adding 4 on the left-hand side of the equation, I'm also going to be adding 4 on the right-hand side of the equation. And if I add this 4 on the left-hand side of the equation, I'll have to add on the right-hand side of the equation. But notice, this 4 is being multiplied by a negative 1. That's where that minus sign is. So that's 9 plus 4 minus 4. The x term is going to be factored into x minus 2 squared. The y term is going to be equal to y plus 2 squared. 9 plus 4 minus 4. The 4's cancel out, and that's equal to 9. Now, the standard form of a hyperbola is equal to 1. So, I divide each side by 9 in order to make sure that this hyperbola is in standard form and equal to 1. So I will have x minus 2 squared over 9 minus y plus 2 squared over 9 is equal to 1. Now, this hyperbola is centered at 2, negative 2. Alright, and this is a horizontal hyperbola. And the reason why we know that this is a horizontal hyperbola and not vertical is because the x term is positive, not the y term. The center is, switch the sign, negative 2 becomes positive 2. Positive 2, negative 2. Okay? So the center is positive 2, negative 2. Now we need to find the focal length. Okay? We need to find C. Now a Pythagorean relation for a hyperbola is that a squared plus b squared equals c squared. So c squared is equal to a squared plus b squared. Now, a squared matches up with 9, and b squared also matches up with 9. So c squared is equal to 9 plus 9. So c squared is equal to 9 plus 9, which means c squared is equal to 18, which means c is equal to the square root of 18. And the square root of 18 is 9 times 2. So the square root of 18 is going to simplify into 3 root 2. Now, because this is a horizontal hyperbola, the foci are going to be adjusting the x-coordinate of the center. So our foci will be 2 plus or minus c, which is 3 root 2, comma, negative 2. So, let's break this down from finding c. A squared is 9. It's the term under the positive term in the hyperbola. B squared is 9. It's the term under the negative term in the hyperbola. C squared is A squared plus B squared. So C squared is 9 plus 9. C is 9 plus 9 is 18. C squared is 18. C is the square root of 18. The square root of 18 simplifies to 3 root 2.
Wouldn't it be the, wouldn't it C, wouldn't C be the square, wouldn't it equal?
3 root 2?
No, stop. Wouldn't it equal, never mind.
Come on, you already started the question.
Alright.
Sounds up, so.
Just say it. I'm gonna laugh.
Okay. Alright. Serious. I do want you guys to ask that. That's a legitimate question.
I didn't even ask the question.
But you were in the But guys, like, yeah.
Isn't it spelled?
I'm
I'm good.
okay.
I'm good.
Take a deep breath.
Yes. Well, no. C squared is 9 plus 9. No. It's 9 plus 9. The standard form of hyperbola is x minus h squared over a squared minus y minus k squared over b squared equals 1. So a squared is 9. B squared is 9. A is 3. B is 3. But a squared is 9. And b squared is 9.
That was my question. I didn't ask.
Okay? So your focal length is 3 root 2. And the center is 2, negative 2. So the foci are 2 plus 3 root 2, negative 2. 2 minus 3 root 2, negative 2. Alright. Here, I want you all to really quickly read that direct instruction expectations and then follow this.
Oh, that's fine. I wasn't paying attention.
Okay. Are there any? All right. What are our main questions here? Any questions before we move on? All right. Please. Please make sure you ask questions, and if you are not making noise but not asking a question, please read the direct instruction protocol. So where did I?
You lost me at 2 squared equals 4.
At C.
No, we answered questions.
Where did I lose you?
At the beginning.
So I lost you that 2 times. So 2 squared. That's just 2 times 2 is 4.
After that, I tried to transfer everything to a piece of paper and I just lost it.
Okay. So that's just a part of completing the square and then factoring and then getting to the standard form. All right. Here. Alex can help you out. So I'm going to move on to the next problem. All right. So the next problem says, state the x and y intercepts of the hyperbola. All right. And we're going to have, I'm going to rearrange this so that the positive term comes first. I'm going to have,
Around 17?
yeah, 17. So we have, so the initial problem is written as negative x squared plus 4x plus 4y squared minus 16y minus 16 is equal to 0. If it's different on your paper,
Oh, it's a different.
change it so that it's what's online. Okay? Now, it would be possible to group the x's and the y's,
What is it supposed to say?
factor out the coefficient for x, complete the square, add it to each side, get it to the standard form of the hyperbola, and then plug in 0 for x to find the y-intercept and plug in 0 for y to find the x-intercept. We could also take out our graphing calculator, and when we take out our graphing calculator, actually plug in our hyperbola, and the graphing calculator will calculate our hyperbola in its the messy form that's presented: negative x squared plus 4x plus 4y squared minus 16y minus 16 equals 0. And this shows us our hyperbola. And if we want to find the x-intercepts, we can see that there are none. This hyperbola does not intercept the x-axis. So we can write D and E for x-intercepts. But for our y-intercepts, the great thing about the graphing calculator is it just shows you what they are. 0, 5.202 and negative 1.202. Wait. Now it's equal to 0. Now it's right. 4.828 and negative 8.28. Very important that you copy the question wrong. Very important you copy down the question right. Copy down. If you type in their question correct, your formula for hyperbola correctly, Desmos will be able to accurately diagnose your x and y intercepts. You just need to know what to look for. So I look at the y-axis right here, and I see that I have two y-intercepts. I have 0, 4.828, and 0, negative 8.28. So as far as showing work for this problem, I would maybe draw my y-intercept and draw my x-intercept, and I would graph the hyperbola. All right, and then graph the x and y-intercept. So I'd have a y-intercept at 0, 4.828, comma 4.828, and then I'd also have it at 0, negative 0.828, and those are my two solutions, so that's what I do to show my work. And as we see for 17, that's what I wrote for the y-intercept. I wrote y-intercept. I wrote 0, 4.828, 0, negative 8.28, and for the x-intercept, I just wrote D and E, because if we see right here, the hyperbola would only have an x-intercept if it crossed that x-axis, but it don't. So it don't exist. Okay. Now, let's move on. Wait, no, sorry. Any questions about any step that I did in this problem, or any clarification that I can make? Don't feel shy to ask me that or share that with the class. Okay. I'm going to go to the next problem. Okay, so for problem 18, we need to find the coordinates of the focus of the following parabola. So this parabola is in the form x squared plus 8x equals 4y minus 12.
Yes.
Now, in order to find information about this parabola, I'm going to have to get into standard form. And in order to get this parabola into standard form, I'm going to have to complete the square. Alright? In order to complete the square, I need to get my x terms into factored form. So, making my x squared plus 8x into a perfect square trinomial, I first take my coefficient of the x to the 1 term, 8, and divide 8 by 2, that's 4. And I take my 4 and I square it to make 16. If I add 16 to one side of the equation, I have to add 16 to the other side of the equation. X squared plus 8x plus 16 is going to factor into, that's a positive 4 right there, x plus 4 squared equals 4y, and negative 12 plus 16 is positive 4. Now, I'm trying to solve for y, okay? So I subtract 4 from each side, and I will have 4y is equal to x plus 4 squared minus 4. So I subtracted 4 from each side. My last step is to divide each side by 4 to isolate y. When I divide each side by 4, I do isolate y on the left-hand side of the equation. And I'm left with 1/4 times x plus 4 squared, and then negative 4 divided by 4 is minus 1. Okay? Now, this matches the standard form of a parabola, which is y is equal to 1 over 4c times x minus h squared plus k. This is the standard form. If c is positive, this is the standard form of a upward facing parabola. So this, from here, I know that the parabola opens up. Yes. Where do they get the 1 over 4c?
No, just the one for the y.
Okay, so I have two terms. I have x plus 4 squared divided by 4 and negative 4 divided by 4. Now that negative 4 divided by 4 just became a negative 1.
Yes.
But I just decided to write that x plus 4 squared divided by 4 as x plus 4 squared times 1/4. So dividing by 4 is the same thing as multiplying by 1/4. Alright, I saw another hand. No, I did. Maybe I was just seeing things. So this is x minus h. Oh, and that's just a k. That's not k squared. So sorry for not making that, but that is just a regular old k that's not squared. And I will give you your conic section formulas on the formula sheet tomorrow. So that should help you out. Now, we have y is equal to 1/4 x plus 4 squared minus 1. This matches up with y is equal to 1 over 4c. So let's figure some things out. This is a parabola.
What number are we on?
We are on number 18. This is for a parabola that opens up. Okay? H is equal to negative. So our center is negative 4, negative 1. That's our center. Our C value, our focal length, we have 1 over 4c matches up with 1/4. So we have 1 over 4c matches up with 1 over 4, which means 4c equals 4, divided side by 4, c is equal to 1. So this is our center. C is equal to 1. Our parabola opens up, which means our focus is going to be directly above our vertex by the focal length. So all I have to do is we have to add 1 to the center, and our focus will be at negative 4, 0. That's where our focus is. We add 1 to the y coordinate of the center, because let's think about it. If this parabola opens up, the focus is directly above the vertex. So if it opens down, we would subtract from the y value. If it opened right, we'd add c to the x value. If it opened left, we'd subtract c from the x value of the center. One thing that you could do is to just graph the parabola in Desmos, graph the answer choices for your foci, and I can show you. If we want to graph x squared plus 8x is equal to 4y minus 12, all right, and then graph our focus, which is negative 4, 0. All right, when we zoom in here, we can actually tell that this is the focus. One, if it's not directly above the vertex, it's not the focus. If it's not directly inside the parabola, aligned with the vertex, it's not the focus. And another thing we can do is create, for example, the y-coordinate of our supposed focus is y equals 0. And if the points on the parabola are not equidistant between the line that runs through the focus and the points on the parabola, then it's not the focus. So this is a way you can... This is... Okay, so... Once again, if you want to try to do this method using your calculator, you would plot the parabola and then plot your focus. Then, for example, negative 4, 0, we solved it was the focus, but then right now we'd just be testing the answer choice. 1, this looks like the focus because it aligns with the vertex. And then 2, we draw a line perpendicular to the axis of symmetry that goes through our test point for our focus. And if it is equidistant between the focus, the test focus is equidistant between 2 points on the parabola, then it is the focus.
So can you pretty much graph like all of these equations?
No. But, and once again, this is one of the tricky ones because you can't just graph the problem in Desmos and know the answer. You have to graph the answer choice in Desmos, test a point to be the focus, analyze that it is the focus, know how to write an equation that goes perpendicular to the axis of symmetry through the focus, and then determine that the points on the parabola are equidistant between the focus and the points on the parabola. Now, it sounds complicated, but if you've practiced enough, when I see a problem like this, I could turn this problem, I don't know, from like a 2-minute problem to a 30-second problem. But that depends on how used to it you are. I think this method is more reliable. Let's move to problem 19.
Can you do your work on the right side of the screen?
You want me to do it like
No.
like that?
No, I just want.
Wait. So like this. So you want the work on the.
On the right side of the screen.
Okay. Is this on the right side right now? Right here.
Yeah.
Okay. Yeah. So.
Probably. At this point.
So.
No.
All right. Let's re-engage. We're focusing on problem 19. 19 is 3x squared. 3x. That's 3. No, sorry. That's 3x plus 2 over x times x plus 1 is equal to a over x plus b over x plus 1. Now here's the deal. Because these two terms are equivalent, and if we wanted to get a common denominator, we could multiply a by x plus 1 over x plus 1, and multiply b by x over x to get a common denominator. And this would put us in a situation where a times x plus 1 plus b times x would have to equal 3x plus 2. So let's think about this. Let's distribute the a and the b. We have ax plus a plus bx.
What happened to the denominator on the first?
Okay, so once you get a common denominator, you can cancel out the common denominator. So ax plus a plus bx is equal to 3x plus 2. Now, let's look at some logic here. Ax plus bx have to equal 3x. And a has to equal 2. Right? Think about this logic. Ax plus bx has to equal 3x, and a has to equal 2. Because the ax and bx are the only x terms, and a is the only constant. So from here, I can automatically see that a is equal to 2. So a is equal to 2. And if a is equal to 2, that means ax becomes 2x. 2x plus bx equals 3. 2x plus bx equals 3x. 2x plus 1x equals 3x. X is equal to 1. So, sorry, b is equal to 1. So a is equal to 2. B is equal to 1. A plus b is equal to 2 plus 1. So a plus b is equal to 3. And that's our solution. Now, this is one of the type of problems where I've done the procedural method, but like I know it's kind of hard to say, but the best way to get this problem right is just if you can kind of see it.
I can't see it. That's what I was going to answer.
And if you can't see it, what you can do is this problem becomes a lot easier if you have multiple choice, if it's a multiple choice test, and you can just plug in A and B and see if it works.
Is this going to be a multiple choice?
Yes, it can be a multiple choice test. Which means if you wanted to plug in values for A and B, you could easily just take your values for A and B and plug them in and see if the equation works. So essentially, you multiply A by the denominator of B. You multiply B by the denominator of A. You group your x terms, you group your constants. You set it equal to the x terms and the constants of what's in the numerator that's left alone. And then, you're good to go.
For the next problem, could you write a little bigger, please?
Yes.
Appreciate it.
All right. So, for the next problem, we need to find, we're just graphing the tangent of pi over 2 times x plus 0.5 minus 3. So here, try.
No, it's not that. It's just like literally like too small.
Okay.
In general.
All right. So here's what we do. You're gonna find a graph, and in that graph you need to find an equation. So we're on problem 20. So the answer really is just what the graph looks like. So if we can find.
No, for 19, the answer is just A equals 2x.
Well, yeah, and then if you want to find a plus b, a 2 plus 1 is 3. So let's look at 20. Y is equal to the tangent of, here's the main trick I want to show you. Writing pi in your graphing calculator, you write the tangent of pi, that's just a p and then an I over 2 times x plus 0.5
Desmos. I'm supposed to write Desmos.
alright, minus 3.
I do this. Good.
And then you see what the function looks like. If we want to actually,
How does it look from this, right?
we'll just we can restrict our x-axis from,
It goes like this.
let's do -1 to 6.28. 6.28. Let's do 3.14. Okay. So here we can really see what's going on here. But yes, Samaya. Yeah. Okay. So this is the tangent function. You look at the shape, you match it up with the graph, and the one key feature is that the x-intercept is 0.2950. So literally, what you could do is you can say you graphed it. You're drawing the tangent function, and your x-intercept is 0.2950. You have your point 0.2950, and that just essentially label all the key features that you can, find all the key features that you can, and match it up with your multiple choice question. If you can do that, you should be good to go.
So the answer is 0.
Well, so the answer is you're going to be given a graph, and then you're going to have to match up an equation that goes with the graph. So this is an example of identifying a key feature of the graph, the x-intercept, to make sure that the equation that you plug in and graph matches up with the equation that you're seeing.
Can you go back to the things I write down?
Yeah. So like this is literally what I would show. Like you graph it, and you're seeing that this is what kind of the tangent function looks like.
0.295.
Yep. Okay. So that just says the x-intercept is 2.95 0.295 0. So actually here I'll write that as, so that's 0.295. All right, so that's 20. I mean, I think 20. You graph your answer choices. You see what matches up with the key features of the graph that's given, or you look at your graphs, multiple graphs, and see what equations matched up. So that, but yet you should be able to do both. But a lot of that's just kind of analyzing key features. All right. Yeah. Yes. All right. Number 21. Pay close attention to this one because sometimes it's the reading the question part that can throw you off. Okay? So this problem, you really need to understand what the question is asking in order to get the question right. Find the equation of the upward facing parabola that has a focus at the center of the circle, x minus 2 squared plus y plus 2 squared is equal to 16. Now what is the center of this circle?
2, negative 2, and
Yep. Well, the x-coordinate of the center is 2, and the y-coordinate is negative 2. So I have a center at 2, negative 2, and reading the question, I see that the parabola has the focus at the center of the circle. So I actually have a focus with the coordinates of 2, negative 2.
so the center of the focus.
Well, so the center of the circle is the focus of the parabola.
Oh,
Yes.
All right. Now, I take my I understand this is an upward-facing parabola. So an upward-facing parabola is going to be below this focus, right? The vertex will be right below the focus, and the vertex will be indicated by a focal length. I think the easiest focal length to have is a focal length of 1. I think it's the easiest focal length to work with. So I'm going to indicate a focal length of 1. And if my focal length is 1, and my vertex is below my focus for an upward-facing parabola, the new coordinates for my vertex are 2 minus 1. Alright, is going to be my x-coordinate stays at 2, but my y-coordinate changes from negative 2 to negative 3. So my vertex is at 2, negative 3. Because I have negative 2 minus 1, that's negative 3. And now I have my focal length c and my vertex. That's all the information that I need. Door, please. Yes. That's all the information I need to find my standard equation of parabola. Because the standard equation of a parabola is y is equal to 1 over 4c times x minus h squared plus k. So plugging in those values, that's y is equal to 1 over 4 times 1. So 4 times 1 is 4. Times x minus h, that's x minus 2 squared. Plus k plus negative 3 is minus 3. So that y is 1/4 times x minus 2 squared minus 3.
you lost me at 1.
Where you lost me where we determined where we chose 1 for a focal length?
Yeah.
Okay. So our focus is at 2, negative 2.
Yeah.
For a upward facing parabola, the vertex is directly below the focus. So the vertex is directly below the focus by a length of 1. So if I'm finding the coordinates of my vertex, it's going to be 1 less than the coordinates of my focus. So my focus has coordinates of 2, negative 2. We're going to have to subtract 1 from my y-coordinate of my focus to go from 2, negative 2 to 2, negative 3. 2, negative 3 is the coordinates of my vertex, with 2 being the h-coordinate of my vertex, so with 2 being the h-coordinate of my vertex, and negative 3 being the k-coordinate of my vertex.
But are you subtracting 1 just from x? I mean, just from y?
From y, yes. Because if I'm looking at my parabola, my vertex is 1 unit below my focus.
And then,
Then I have to take the standard form of my parabola. Y is equal to 1 over 4c times x minus h squared plus k. I plug in 1 for c, 2 for h, negative 3 for k, and that's how I get y is equal to 1/4 times x minus 2 squared minus 3. Now I am going to give you guys the standard form of the parabola on your formula sheet, so that should help you once you find c, h, and k. Make it a matter of plugging it into your standard form and then simplifying.
Wait, so how did this center
So this is what's given in the equation. The center of the circle becomes the focus of the parabola. So it's a multiply question because you need to find the center of a circle. Like you have a circle equation. You need to find the center. That becomes the focus of a parabola. Okay? Yes. Yeah. Now, I'm going to go on to problem 22. Okay, this one we're gonna have to analyze this step by step. All right. Also, plane A, I meant plane 1 in this. For plane A, I meant plane 1. Okay. Now, yes, restroom. Yes, go ahead. Now, the magnitude. Plane 1 is flying with a bearing 40 degrees west of south. So, drawing my directions where I have south and west. If I'm going west of south, I start south, then I rotate west, okay? So that means what direction is south? What angle direction is south? Is south 0, 90, 180, 270, or 360 degrees? 270, right? So if we're 40 degrees west of south, we subtract 40 from 270. So we have 270 degrees minus 40 degrees is 230 degrees. That's our compass direction, or that's our direction in degrees. And then, I'm going to call that theta 1 our first direction. Now, we have another direction. We have 60 degrees south of east. So we're moving east and we're rotating south. Okay? So that's east and that's south. Here, we start at 360 and then we subtract whatever reference angle is from east. So 360 minus 60 is equal to 300. So our direction 2 is 300 degrees. That's equal to our direction 2. Our magnitude for direction 1 is going to be 600 miles per hour. So 600 miles per hour, that's magnitude 1.
Why is it 600 miles?
Because it's given that plane 1 is flying with a speed of 600 miles per hour. Plane 2 is flying at a speed of 70 miles per hour less than plane 1. So 600 minus 70 is going to be 530. So 530 mph, that's the magnitude of plane 2. So now, I'm going to find the component form of plane 1 and plane 2 after 1 hour. Okay? So after 1 hour, plane 1 is going to have the location 600 times the cosine of 230. And then it's going to also have the component 600 times the sine of 230. That's the component form of plane 1. The component form of plane 2 is 530 times the cosine of 300. Comma 530 times the sine of 300. So what I wrote down, if it's hard to read, for plane 1, I wrote 600 times the cosine of 230, comma, 600 times the sine of 230. Then 530 times the sine of cosine of 300, comma, 530 times the sine of 300. Seeing this in the calculator, I'm going to calculate 600 times the cosine. Make sure I'm in degree mode. I am. Times the 600 times the cosine of 230. And then I'm going to calculate 600 times the sine of 230. I'm then going to calculate 530 times the cosine of 300. And then I'm going to find 530 times the sine of 300. Alright, so this is going to give us our horizontal and vertical components. So after 1 hour, plane A is actually going to be in the position negative 385 point. I'm going to just round it up to one decimal. 0.7, comma, negative 459. 0.6, and plane B will be in the position 265, negative 459. From these two, if these two planes are in these two positions, we can find the distance between these two planes using the distance formula. So the distance formula is x2, the square root of x2 minus x1 squared, minus y2 minus y1 squared. So our distance after 1 hour, so our 1 hour distance, here, I'll send the email to you during 4th block.
During 4th block?
Yep.
Okay, thank you.
Yeah, so our 1 hour distance is going to be negative 458.99. So here's how we would solve this. We do x2 minus x1, the square root of x2 minus x1 squared, plus y2 y1. So let's plug it in. We have the square root of x2, 265, minus x1 minus negative 385.7 squared. As that's x2 minus x1 squared, plus, let's do y2 minus y1 squared. So that'd be plus negative 459. Alright, minus 459.6. So minus negative 459.6. 459.6 parentheses squared. And so that's a big equation, but I can plug it into my calculator. I find the square root of 265 minus negative 385.7, close the parentheses, square it, plus negative 459 minus negative 459.6, close the parentheses, square the term, hit the enter button. So that's going to be 650.7. So 1 hour distance is 650.7. Yes? Yes. All right, 650.7, which means I multiply this value by 4 to find my 4-hour distance. That's going to be 2602. All right. For people that have already attempted this, what did people get 2602 or okay? So for 23, we have our distance from the center to the top. All right, that's the height. That's equal to 50. Somebody in the door. So that's B. That's equal to 50. A. If 2A is 150, so 2A is 150. That means A is 75. And the distance from the center to a whispering dish, all right? If a whispering dish is at the foci, then that's equal to C. So now we just need to find C. We need to find the focal length. So that's just going to be, for ellipse, A squared minus B squared equals C squared, which means C is equal to the square root of A squared minus B squared, which means with your calculator.
Mr. Wall.
Yep. Yes. C is equal to the square root of 75 squared minus 30 squared. And that's going to be equal to 68.738. Wait. That's 50, right? So let me just recopy that because so that's a 50, so just replace that 30 with a 50. So C is equal to 55.901. Let's make sure I indicate that B is 50, not 30. So 55.906, C is equal to 55.906. And that's their focal length. 55.9, that's the distance from our center. All right, now what I can do is I'm gonna solve 20, figure out where I went wrong by solving 22 like a law of cosines problem. So plane 1 is 40 degrees west of south, so that's 270 minus 40. That's 230. So this angle right here is 230. But really, the way we can look at this is if that's 40 degrees west of south, that means that this angle right here is 50. Because that angle. And then this will have a magnitude of 400. And this will have an angle of 180 minus 50. That'll have an angle of 130. Okay. And then we'll get there in a second. Then I stop here and I now make sure the direction is 60 degrees south of east, so that's 300 degrees. So All right. So 60 degrees south of east. Here, let's. Here. Redraw from the start. Okay. You have a radar station. One is going to be 230 degrees. So right here. The other plane is flying at 300 degrees. Okay. So, analyzing what's going on over here, the distance between 230 degrees is going to be, and 180 right here. That's going to be 50 degrees right here. And then 300 degrees and 360, that's going to be 60 degrees right here. That's going to be 110 degrees combined right here, which means this angle is 70 degrees. And that also means jet plane 1 has a magnitude of 400. Oh, sorry, 600. And jet plane 2 has a magnitude of 530. And we just need to find this direction right here. The reason how I found these angle values is essentially I could draw a line straight down the middle of this triangle and find out the missing values. If this is 40 degrees to the south and this is and then this is 30 degrees to the north. So now I can use the law of cosines. Call this value x. X is equal to the square root of 600 squared plus 530 squared minus 2 times 600 times 530 times the cosine of 70. So I find x, so we have the square root of 600 squared plus 530 squared minus 2 times 600 times 530 times the cosine of 70. And that is 650 times 4 is 206.02. Okay, so x is 2602. Yes, so x is equal to 650.767. X is equal to 650.67. And then 4x, which is our time after 4 hours, is going to be 2602.69. And so our actual answer for 22 is 2602.69. So I guess that is the magnitude of the resultant vector isn't necessarily the distance between the two planes. All right.